All right, we should be streaming and recording now. Let me just check the.
Hello, John.
See if it's actually up. Yeah, it looks like it is on. So welcome everyone to the next latest edition of the Beehive FreeBSD Office Hours. And we will get started.
Hi, everybody. My name is Peter Green. I'm a FreeBSD committer, mostly working on Bhyve. Welcome to the first Beehive Office Hours of this year. Probably won't be too long. There hasn't been a huge amount of activity in the source tree in the past month or so, but we have a couple of things we can go through. I can just throw it over and we can probably do some quick intros from the other people on the call here. Mark.
Hi, I'm Mark Johnson. I'm a very occasional contributor to Beehive, but I'm hoping to kind of expand my contributions there over the next year. Yeah, I've been a FreeBSD developer for a while, and I'm quite interested in Beehive.
Ed.
I am Ed Mast. I work for the FreeBSD Foundation and manage all kinds of things that the foundation takes on project-wise. And I have done not an awful lot with Beehive to date, but am interested in helping facilitate these sorts of discussions. And I think there's a lot of potential for interesting things with Beehive in the future.
Jason.
Hi, my name's Jason Tubner. Our organization is a large consumer of Beehive. We use it across various operating systems, specifically using the Uefi access to Beehive. We have 50 sites across Australia that uses Beehive successfully, and is production proven over the last 4 years. So we're a heavy tester of Beehive.
And John.
I'm John Baldwin. I work in various things in the kernel, and I also work a bit with Beehive, and I've tried to help shepherd some patches in the past. And also I've used Beehive as a development platform, so I've hacked on some things that are been useful to me for making it development friendly.
See, we have a FreeBSD Foundation person, or is that just the streaming account?
Yeah, that's just a
you dummy.
Yeah.
Should put a face there and get something going.
Picture beastie.
Okay, so we have a fairly small agenda today, as I mentioned. This is the first talk after holidays, and everybody's had a welcome break. There hasn't been a huge amount of activity in the source tree. Just to talk a little bit about some commits that have gone in that I guess I would consider notable. And it's a fairly small list. So also, I'm not sure if the URL for this has been posted. Where's the this is just the link to the wiki there. So just to quickly go through these, there was kind of a historic commit when Beehive was first implemented. It didn't have any device emulation at all. There was a single paravirtualized console, and that was to avoid having to do an emulation of a UART, which, while it sounds fairly simple, actually is a fair bit of work. Where a paravirtualized console, you just don't have to do anything, just accept whatever has been written and then write it some way. So that was extremely useful in getting Beehive working, but has since become basically unused. There was also a GDB stub that was also paravirtualized, and it had also essentially become unused. The only consumer was FreeBSD, and no one had remembered anybody using it for a number of years. So in line with sort of FreeBSD's policy of removing dead and unused code, those historic artifacts were finally removed from Beehive, and I don't think anybody even noticed, but it's still still in the archive if people want to resurrect it. There are drivers for these in FreeBSD that could also be resurrected if need be. The next one was a fairly large commit, and had been some work that had been done over quite a long amount of time. And that was fixing issues with Vnc clients. Vnc is sort of a very loose standard, and there are numerous clients out there that all implement things in different ways. Beehive itself has a very small Vnc server that isn't really meant to be feature rich. It's meant to be the bare minimum that can be used to get a system up and running. Unfortunately, it didn't work too well with some Vnc clients, and it didn't work at all with others. So I think these issues have mostly been fixed now. Tiger VNC was very choppy. That now works. macOS built-in VNC viewer didn't work at all. That now works and works okay. Along with doing this work, there were actually some performance improvements as well. Mouse tracking should be a lot smoother than what it was before. The screen update is a little faster, so interactive performance is slightly better. And it actually uses less CPU when idle. It used to kind of sit on about maybe 2.5% CPU when you weren't doing anything. And now that's kind of dropped down to about 1.9%. So just kind of a slight performance improvement there. Fixing Tiger VNC was actually kind of important. So I'll go into that in the upcoming work section. Last little bit of work, it's kind of minor, but it's useful for some people. Previously, Beehive only supported 2 serial ports. That's the standard COM1 and COM2. But some people had a need to have additional serial ports. So with a very minor change that was contributed, now COM3 and COM4 are also supported. It's kind of useful if you need to have an extra login other than just the console, or maybe you want to use a non-standard port for debug or something like that. The next thing that I wanted to talk about was upcoming work. So I guess there are quite a few reviews outstanding. I've just sort of pulled 2 randomly here. Probably the largest one is the warm migration review. So I'm not too familiar with this, so I might hand it over to John, who I know is familiar with the save and restore work, and this is an extension built on top of that.
Yeah, Elena uploaded it who worked on the save and restore work at UPB. She uploaded it, I think, a week or so ago, and I haven't really had a chance to dig into it. I know I've talked with her about how it works. It's basically still doing save and restore, but over a socket. And it's a stepping stone to live migration where you actually do an initial send over the socket and then do continuing sends while leaving the guest running until you do a final freeze and send the rest of the guest state for live. So it's a stepping stone to that point. But I haven't yet got a chance to look at it in detail. There's some other suspend and resume fixes I need to look at from before. I know one of the folks who's been using suspend and resume They had several fixes. There's also a patch that they have some fixes to. The same folks who have been using it have fixes to a UPP patch to enable multiple instances of a single device to be saved into suspend and resume. So that's also in Fabricator for review. I don't think it's a prerequisite for the warm migration. I think they're kind of orthogonal. But those are the ones that I'm aware of that are outstanding.
But I think also this is a prerequisite for live migration. Right?
Yeah,
kind of
yeah, live migration
development.
built on top of this one. And that one will have more stuff because, whereas I believe this one is really just adding the ability to send over a socket instead of to a file for the state. Live migration needs kernel assistance to actually deal with knowing which pages in the guest address space are dirty since the last scan. So that's a bit more invasive.
Oh, okay. So just on the dirty pages thing, I mean, I guess there's some potential for kernel work there because at least VTX has the ability to log pages that have been accessed.
Yes. So Elena has changes, and we talked about it. We talked about it at BSDCan 2 years ago. Last time we got to be in person, and I know I've had some email threads with Mark and Alan Cox about it. I think the current design is effectively to have like a single dirty bit kind of in the VM page T that is like a shadow copy of what you have from the dirty bit from the EPT tables, and to kind of use that to just kind of as you do a scan, you clear the dirty bit as you sync the page across, and then later when you do further scans, you depend on the dirty bit to decide if the page has been dirtied since the last time you sent across. To kind of make your subsequent scan smaller and smaller. I think the current implementation they do like up to 4 rounds. And if it takes, at that point, they just kind of give up and freeze and send whatever is left. But they found that at least that 4 rounds tends to be enough that you get down to a pretty small working size for the last bit of stuff you have to send across. So they haven't posted it for review yet, but I do know they have it. And if they have been able to run some form of it in their testing at UPB.
Oh, and I think the other thing too was that currently it's Intel only. There wasn't AMD support.
That might be true. I know I saw a thread, I think recently where someone had tried to suspend and resume and had limited success on AMD. So I believe that the UPB folks only have Intel hardware to test with. So I think it's really only been tested on Intel hardware.
Okay. All right, the next bit of work I had here was VNC non-US keyboard support. So this has sort of been coming in a number of different ways for quite a long time and had a number of prerequisites. So the problem is with VNC that the protocol itself removes a lot of information from the keystrokes that people are hitting. And in particular, it basically goes down to sort of X11 level in terms of sending the scan codes. So if you look at the path, what happens from a user interacting with Beehive, they're usually on some sort of system that has keyboard hardware, and that gets converted into some sort of generalized form, which then goes into a Vnc client, which then converts that into X11 scan codes, which then go across the network, which then get received by the Beehive Vnc server, which then has to translate them into PS2 scan codes. So there's a lot of kind of translation back and forth between different formats, and there's some information lost when doing that. So in particular, what happens when people are using a non-US keyboard, which might have the English pound sign instead of a dollar sign, that information gets lost by the time it gets to Beehive. And if somebody installs, for example, a foreign language version of Windows, the keys that they enter come out different on the screen than what they expect. So turns out there's 2 ways to fix this. There's one quite large involved one, and there was one fairly simple one, but limited. So the initial goal was to try to get the simple but limited one working. So the way that works is with an extension to the VNC protocol, where instead of sending X11 scan codes, it actually sends PS2 scan codes. So then there's one level of information loss that was removed. The issue with that is that the support in Vnc clients is quite limited. Basically, Tiger Vnc is the only popular client that really supports it. So the problem with Tiger Vnc is the performance with Beehive was very poor. It has issues with the number of rectangle updates that Beehive was sending. However, the fix that went in recently for Vnc clients fixed up Tiger Vnc to the point that it's basically usable as a client. So since that's now usable, we can merge in the fix that was contributed, and it's in a FreeBSD problem report, which is a diff that basically intercepts the PS2 scan codes and then injects that directly into the Beehive PS2 emulation. So then the actual foreign keys will then start rendering correctly. There is one other issue with that, in that the PS2 keyboard has a number of different scan sets. It's like 1, 2, and 3. The VNC protocol uses scan set 2, but Beehive implements scan set 1, so we have to go through another layer of translation there. Fortunately, that's almost completely lossless, but it's just sort of annoying. So hopefully that fix will be able to go in fairly soon. I mentioned another way of fixing this, and that's to use translation tables. That's a little more complicated in that basically every foreign language has to have a translation table in Beehive, which is used to convert the X11 scan codes into the correct PS2 scan codes for that particular foreign language set. The issue, well, the advantage of that is it works with every VNC client. The disadvantage is that we have to have tables maintained for each language that needs to be translated. And that's kind of ongoing work. It's probably going to take a while to be complete, just because of the number of different foreign language keyboards that exist. But fortunately, the Tiger VNC one is probably a good enough workaround for the short term. So yeah, I think this work should probably go in the next couple of weeks, I think. I guess I should probably talk about Uefi a little bit. The current issue with EFI is that it's based on quite an old build of the open source EDK2 repo. The branch snapshot was taken in 2014. Now, I mean, bootloaders don't really change a whole lot, so it's not the end of the world. It's still quite functional and does the job. However, EDK2 development is kind of proceeding at a fairly quick pace. And we've been missing out on some changes and bug fixes and feature enhancements. The other issue too is that the older Uefi that Beehive is using now is built with Python 2.7, which is being deprecated. And manually converting that over to Python 3 doesn't look very feasible. So the solution for this is to, of course, try to move forward to a newer EFI. And in fact, what's being done is maybe even better than that. So Bex Cran, who was a FreeBSD contributor, has managed to upstream the Beehive variant of the EDK2 build into the main EDK2 source tree. So what that gives us is basically a up-to-the-minute version of EDK2 that's available. The only issue is that we haven't quite got all of Beehive, the existing EFI functionality, into upstream. So CSM, which is the BIOS emulation of EFI, that's present in the existing Beehive EFI isn't working, and it seems like a very big job. It involved a lot of changes in generic EFI outside of just the Beehive portion, and that may be difficult or impossible to upstream. The way out of that is that not a lot of people really need BIOS boot. When this was first done back in 2014, there were still a lot of operating systems that didn't support EFI. But that's pretty much not an issue anymore. Every guest generally has an EFI boot, and they don't really need BIOS boot anymore. So it's not a real urgent issue, and certainly not a gating issue. There's some other minor details. We still need to get 64-bit PCI bar support working. At some point, it'd be nice to have persistent EFI non-volatile variables, but it seems to be in almost good enough shape now that we can probably retire the existing EFI suite and transition to this new one. It's probably not going to happen before FreeBSD 13, but I'd say sometime in the first quarter or half of this year. John, did you have any work upcoming?
I do not have anything else. I do need to rebase my config stuff, especially for COM3 and COM4. And Rob, I can't remember his last name. Is it Rob Wing? Who's done some? He's had a couple of different patches recently. He gave me some review feedback I need to go fix. He noticed an error I hadn't noticed in the ASL that was generated, so, among other things. But that's all. My plate is mostly full with non-Beehive things for the last few weeks, unfortunately.
John just reminded me that another big piece of upcoming work is ARM v8 support. So there's a very large review that adds support for ARM v8. I think currently it works on Espresso Bin hardware, which is 8.0. And I think the ARM fixed virtual platform emulator is also supported. But I think if it works on Espresso Bin, it's probably going to work on any other ARM system, given that 8.0 is a baseline.
You have to have the right interrupt controller, though, right? And not a lot of the SoC boards don't have the right version of GIC, I think, to support what you need for rerouting interrupts.
Right. Is it GIC v3 or v2?
Something. I think it's v3 is what my understanding of what they were using is what it required.
Okay.
Like I think the Pi boards all don't have like a v2 GIC, for example.
Yeah, there was a discussion in the chat about this, and it sounds like that in particular the Raspberry Pi 4 is interesting because it's cheap and ubiquitous, but isn't going to work.
Oh, that's right. It's GIC v2, I think.
I think so.
No, I know the v3 that I have is. I wasn't sure if maybe the v4 they would finally have done a newer one, but perhaps not.
Yeah, well, the original Raspberry Pi 3 has a proprietary interrupt controller. So you would have to do like a software emulation of the GIC, and I think that just kills performance. I mean, you know, my general impression of ARM virtualization is you have this gigantic menu of options. So in particular, 8.1 has virtual host extension, which is kind of a huge performance win. You don't have to ping pong between EL1 and EL2, but I don't think FreeBSD can run at EL1 with VHE enabled at EL2, so you'd have to make that change first. So yeah, it's ARM is a lot of work, and it's probably going to take a long time to get in. So next on the agenda were talks. We didn't really have any this week. But last time we had a suggestion to try to do some demos. So I'm going to have a go at that. So what came up on the list was, there's been a number of questions about just running Red Hat or Santos under Beehive. It's actually been supported for a very long time. I mean, Linux was the first non-FreeBSD guest to be brought up. And it was actually ancient version of CentOS. With each version, there's always been some sort of minor change. I guess another historical thing was that running CentOS was the initial motivation to get Uefi working, although we ended up implementing grub Beehive, which was sort of a quick, was intended as a quick and dirty way to get Linux working, but it just became too hard to kill, so it still exists. And that was really the main way to run Linux, and especially CentOS, because they didn't have Uefi support for a very long time. However, with CentOS 6 being end of life, CentOS 7 and above has quite good Uefi support. So I think that's really the preferred way to boot RHEL and CentOS these days, and that's what I'm going to use. Set up my machine here. Let me see if I can get this window. Okay, so this is just a small Ryzen system. So I'm going to do a CentOS 7 install first. And for CentOS 7, I just have the minimal install here. Once upon a time, RHEL used to be made in a whole bunch of different size distributions that allowed you to kind of, pick the everything DVD, or you could pick the boot only DVD. But over the years, they've sort of cut that back, and now you end up with either a boot or minimal, or the everything, which is 10 gigabytes. It's just enormous. So I'm going to do all this manually as well, not using VM Beehive, which might be a bit of a mistake. VM Beehive is probably vastly easier, but I can just show the low level details. So the first thing I'm going to do is just create a 30 gig disk image, and that'll be used to have the install dumped on. I've already downloaded, that's the latest version of 7. That's the 2002.009 build. And this is just a minimal ISO. It's actually not that big compared to the everything, which is just absolutely enormous. And if you're not in the US, it takes forever to download. So this first install, I'm going to use the frame buffer. I'll do a serial console on after, but The install is a little daunting on the serial port. You really want to use the frame buffer, or you want to use the VNC server that Santos can also be installed with. Right, so this is a fairly standard type of BSD install. I have 4 CPUs. I'm using AHCI-CD for the ISO, and VirtIO block, which actually works very good on Linux for the image. VirtIO for networking. Just a standard frame buffer with the default parameters, except I am asking it to wait. I always use XHCI for the mouse because it uses absolute coordinates and tracks very nicely. That's the current Uefi build. I'm just giving this system 4 gig of RAM. So the next step is to fire up the VNC server. And I'll just flip over to this window. All right, so I usually don't bother with any of these other than install. All right, and this is the standard Centos install screen. And I usually just kind of flip through these. All right, so the one thing we have to select here is what disk we're going to use, and we kind of have to double click here. So we're just going to use VirtIO block and just automatic partitioning. I'm not going to bother encrypting this or adding additional partitions. Right, so the network, it comes up off by default. So I have a tap device connected to a bridge to the outside world. So I'll just flip that on. And by default, it's just DHCPs. So everything is fine there. All right, I'll just set this to FreeBSD. Thinks it's a weak password, so you just have to double click on done. Bother creating user. So away it goes, and you can see just down the bottom here, it's just running through a minimal install, which doesn't take a massive amount of time compared to a GUI install, but the progress bar is maybe not exactly proportional to where it is in the install process. So I guess, if you look at the difference between this and say a FreeBSD install or even perhaps an Ubuntu install, it's not really like a linear walk through what the install options are. You sort of have this one page where you have to go through and answer questions, and it's not always obvious as to why you have to do it. It also hasn't been updated in maybe forever. I guess it's based on a tool called Anaconda, which has been around since the early days of Red Hat. It still seems to be the same technology underneath. So it feels somewhat dated, I guess. It doesn't have the slickness of, say the Ubuntu installer.
We won't talk about our installer.
Well, I kind of like, booting different guests and seeing how they do it and comparing. I mean, if you want the ultimate in a minimal install, you look at something like OpenBSD. I think it's a complicated issue, right? You don't want to spend a massive amount of resource on some slick GUI installer, but then it is the user's first interaction with your system.
Yeah, we can have a whole office hours on installer plans at some point.
All right, we're kind of in this end part where it's finalizing things here. Once again, the status bar is just all over the place. You don't really know where it is. The main thing is if you've done it before, you kind of have an idea of how far it's gone.
For a perspective, Peter, what hardware is the underlying host operating system running on? Just so people can understand what the guest is compared to from a performance perspective.
This is Ryzen 4000, so it's kind of like an Intel NUC, but the AMD version. So it's 8-core, 2 gigahertz. It's a reasonable small box. The VM itself, I just started up with 4 vCPUs. All right, so that's it. That was a minimal CentOS 7 install. So one reboot is required, and this is kind of a limitation of the existing Uefi because we don't have persistent NV vars. I have to restart it with the ISO removed or have the hard disk ahead of it in boot order.
Just for other viewers out there, VM Beehive handles that gracefully, so you don't have to worry about it. If you've done your CentOS install and issue the restart, it ejects the disk and manages to restart the guest for you.
All right, so I just restarted the VM with the exact same parameters, except I removed the CD. So I'll just connect back to that. So this is what Uefi looks like now. Basically, we're in Grub. You can see CentOS 7 doesn't support the Ryzen 4000. And that's it. A minimal install CentOS is very minimal. You really don't get anything. Just a command prompt. Whoops. See the 4 CPUs there. Not a lot going on here. I don't know if anybody has any favorite Linux commands. And you can see we're a long way away from FreeBSD.org there. All right, so that was a GUI install. So I'm going to show what a serially install is like. If you thought the GUI install was maybe not the best. So what I have here is pretty much the same thing, except I'm going to just remove the GUI part and just add a serial and then MDM serial port. I'm still going to use EFI though, so it's basically a serial boot using EFI, which works just fine. But there is one little trick here. So let me just get the oops. Oh, it doesn't want to get my serial port. Just trying to pick up the NMDM window here where serial port output is. Is that the right window? No. Too many terminal sessions here. Anybody see what window I've got here? I'm getting lost in a sea of terminals.
It looks like this one is the one where you're running Beehive itself.
Okay.
And that's your serial console, perhaps?
Can you see the CU there?
Yeah.
Okay, it's not highlighting the window, that's all. Okay, so I'm just going to start up Beehive. Oops, what happened here? All right, so didn't find a bootable image there. It is a good demonstration of the EFI shell application, which has a bunch of different things. One of the things that we did in the older Beehive is just change the colors, so it's not kind of standard EFI. It's a Leon edition here where we have green for the prompt. And this is what happens if I can't find a bootable device. So I obviously did something wrong here, but my command line looks kind of fine. All right, let me just. I know what I did. So I'm using the same VM name for this as what I did for the previous one, but because Beehive basically keeps the guest image in memory, EFI has a RAM disk and it's always at the same location every time you boot. So the previous guest had set boot priority and it was written to its internal RAM disk. So when I started EFI again, it picked up what it thought was the non-volatile vars, which was instructing it to boot from a disk that had been zeroed. So it did actually fail to boot. So the simple fix of that is I'll just delete I'll destroy the VM. So now we have a clean slate. So now when I start it, we're now at the serial output of EFI, which is, to my mind, is very hard to understand what's going on here. If you kind of look over on the right, you can see the cursor moving. That's actually selecting one of those three options. Now, if I just boot this, Linux will think that there's a graphical console and you'll just get nothing on the screen. So what we have to do here is edit the Linux command line. So there's kind of a simplistic editor here, just E for edit. So what I'm going to do is just add one extra little bit here that will force a serial console, and we'll also get some extra output. So that's what the new Linux command line is like. I just had to put in TTYS0 as the main console. The early print K just gives you a little bit of extra when you boot in case you want to scroll back and see if anything was probed. So now Control X will exit that menu and boot with those additions. All right, so now this is the Santos serial install, and Ed, you mentioned that you didn't really like, you thought the FreeBSD one may not compare. Well, I think the FreeBSD one compares very good with this one. There's a lot of information here. It's kind of hard to know what to really do. You know, there's a little exclamation mark, which means that you haven't set it yet. So for example, to set the time zone, I have to go through a couple of layers here. It auto-configured the installation source and the selection. It didn't do the destination, so we have to do that. We're going to we'll just do that. We'll do network configuration. We'll apply the network configuration in the installer. And we'll just do the root password, which will be FreeBSD. Yes, it is weak, but we'll use it anyway. Okay, so I think there's just, oh, we have to do 4 again. Say that we did want the minimal install. Okay, so we have enough X's, so then we can do the install. This one, in a way, gives a little more information than the GUI install, just because you're kind of watching numbers scroll past, almost like a package install, as opposed to a status bar, which is not, doesn't really give a good indication of where you are in the install. Plus, you can also see this is a a minimal install of Centos, and there's a lot of stuff in here. Lots of Python utilities. and lots of wireless firmware. The little status bar down the bottom where you can switch over between, like a shell or the log, that doesn't actually work. I'm not sure if it's just some issues with VT emulation or something else, but basically we're unable to toggle between those. So yeah, this is the point. Even in the GUI installer, it just kind of sits there and you don't really know what's happening. I think we've got a little bit more time of this before it installs the bootloader. Or it's frozen, who knows?
No, that's quite typical. Ubuntu has the same issue when it's trying to set up all the init RAMFS and all that sort of stuff.
Oh, okay. I think it actually does print, at least in the GUI, you can see when it is doing some of that. I mean, maybe this is just a limitation of the serial install where there's, get status updates during this portion. Oh, there we go.
You can show off the lack of Control T.
Lack of Control T, yes. Well, actually, does the FreeBSD installer support Control T? I'm not sure that it does either.
Maybe not the installer. Well, I mean, it's in the kernel, but.
All right, so I just restart it, and then basically in the same fashion as with the GUI, I just restart without the CD-ROM. All other parameters are unchanged. There we go. It remembered that it was configured on the serial port, so it'll set up to boot on the serial port. And there we go. That's basically exactly the same as the GUI install, just without the GUI. Yeah, there's the Ryzen 4000.
So a question we had on IRC is there a correct solution for distributions that expect the EFI variables to be persistent?
So I guess there's two ways to do it now. One is to never delete your VM because they'll just stay in RAM. That's not particularly useful. So I guess there's a couple of parts of that. One is when it changes the boot order and expects the boot order to persist. There's really nothing that can be done there. And that's why I had to remove the CD. So the current Beehive EFI, the UDK 2014 base one, it has a very simple algorithm to work out what the boot device is. So it assigns a priority to what it considers removable devices and fixed devices. So removable devices always have priority. So that's why the CD, no matter where you put it in the slot order, is always picked up as the boot device. For hard drives, it'll basically probe them in PCI slot order. And because it doesn't take any notice of the boot order in the NV vars, and that's just a limitation because it's a very old EFI. The other issue that I think comes up even more is a non-standard location for the EFI loader. So, you know, the default is /boot/EFI bootx 64.EFI. And I mean, I think even in just FreeBSD on bare metal, that can be an issue where a lot of OSs initially they would write that, but if you want to kind of dual boot, often they'll put down a name which is not the standard name, and they'll use an EFI variable to point to that name to specify that to boot. So the current Beehive EFI doesn't work with that at all. It looks for the standard location. If it can't find it, it just fails to boot. So the workaround for that is you can just go in and copy the non-standard name to the standard name. So for example, if you boot Ubuntu and it puts down Ubuntu x64.EFI, you can just, you know, copy that to boot x64.EFI, and that will still work. It's kind of annoying. Another solution is to use Refind, which is like an EFI boot manager. So basically you copy that down, you install that, or just copy it manually down, and it will list all the bootloaders and allow you to kind of graphically select which one you want to use. I think people have had a fair bit of success with that. But they're all workarounds. I mean, the real solution is we have to put in pflash support. So there was a review for that quite a long time ago. I think we kind of have to resurrect that. And I'm not too sure that it was for backwards and forwards compatible as well. I mean, the other issue with EFI is that you're going to have people that run on older versions of FreeBSD, but because the ports spans across all versions, they're going to pick up the latest EFI, but we still want older versions of Beehive that don't have support for pflash to work. So that's kind of the complication. You just have to make sure that, you know, you don't put out a version that only works for current, and then everybody else on supported or older versions of FreeBSD can't boot anymore. So it just means that you have to put in a little more work to kind of get features in EFI working because of the backwards and forwards compatibility issue. I think that's a really long way of saying no. There's not a good solution.
Well, in IRC, they found it was helpful. So I think even renaming the EFI probably fixes, I think, the user's immediate problem. That might be a simple workaround they can use to get it to boot. A few other questions I could bring up. We have about 2 minutes left. But I could throw some at you if you wanted.
Yeah, there's a Q&A section. So yeah, you've got it pretty well listed there in the chat there, John. So I suppose you can lead off and fire away.
So the first one, which I'll hand to Peter, is I had a question about what block device model is the best one to use. And I think in this case, not for a CD, but for storage, because we have several. We have VirtIO, we have HCI, we have NVMe, and we have VirtIO SCSI.
Yeah, so all of those have kind of pluses and minuses. I mean, VirtIO block was the initial one done, and para-virtualized and supposed to be better performance. The problem was outside of open source Unix, it's very iffy. So in particular with Windows, the VirtIO block drivers from Red Hat are quite poor in performance and often fairly unstable. It's the same with VirtIONet. You know, there's this kind of folklore as to what revisions to stay away from, and always the latest one always seems to be the worst. AHCI is purely for compatibility. It was basically done because, you know, there were guest operating systems that didn't have support for VirtIO block, and in particular, Linux didn't have VirtIO block in the installer images. So you weren't able to install off of VirtIO block. So AHCI was really done to get AHCI CD support, which enabled Linux installs to work out of the box. You didn't have to repack the init RAM FS, and that's, you know, a pretty daunting task, even for people that are really used to doing that. Performance is, you know, not at all good for AHCI. It's purely compatibility, but it's just guaranteed to work and everything. So I generally use it when I ever do a CD install where performance doesn't really matter that much. NVMe, I think, is really the solution for Windows and maybe even just open source Unix. It's kind of the highest performance storage, and it's been written with parallelism in mind. So, you know, it has like a lot of queues. You can assign queues to all CPUs in the system. The drivers are generally written with performance in mind. And it works really good out of the box in Windows. So I would much rather see people use NVMe for Windows than to have to go and install VirtIO block drivers that, you know, are low performance and sometimes just don't even work. So I mean, I see NVMe as kind of the de facto storage for guests. VirtIO SCSI, I guess it's kind of interesting. It solves a problem in fan out, where generally with device models, you usually have a one-to-one correspondence between a PCI device and a storage device behind it. You can't really chain multiple disks off VirtIO block, for example. I mean, AHCI, you can have up to 32 disks, but that's already low performance. So VirtIO SCSI, it kind of gives you the ability to, you know, have a large fan out in disks, and also it gives you the option to do SCSI pass through. So if you have kind of a device that might have some special requirements or features that are only available with SCSI direct access, it allows you to do that. But it's a fairly arcane thing, and it you know, needs FreeBSD support because it needs the SCSI user space backend. So it's fairly arcane. I haven't really heard of much usage of that.
I guess you could use it to hook up to like a remote iSCSI thing with FreeBSD, perhaps.
Oh, that's right. Yes.
That might be the other use case for it, is to use an iSCSI one.
I'll sort of give a production rundown of what we use for storage in our production. We're still based on the 11 series of FreeBSD for our production devices. So basically all we have access to is VirtIO block for both, well, AHCI obviously, but from a performance Windows, we run OpenBSD guests and Windows Server 2016 or Windows Server 2019 guests. So VirtIO block is the most consistent one there across the base and supported in 11.4. We're moving our devices to 13 when 13 is released, which will mean that we can then switch all our guests to NVMe, and that's purely a decision that we've made internally because of the flexibility of NVMe, because a lot of our devices are just backed on SSD. So having that NVMe driver will improve guest performance on Windows servers, and that just makes it easier for us to run the OpenBSD at the same level as well.
So the next question I saw is, what is the status of Non-Pfs support in both Beehive and FreeBSD? And I can probably take a stab at answering this one. There is support in Beehive that'll ship in 13.0. as far as a VirtIO 9P device model, and it can export. I think each device can export one file system, so you can have multiple devices for multiple shares. There is not currently a guest for FreeBSD clients in the tree. There is a review that has a patch set that originated in Juniper that they've used a bit with QEMU internally. But I think when I've talked to people who have tried the patch set, it is a bit bumpy. It is probably not ready for production use. So at the moment, if you're using 9PFS, you could use, for example, on Linux guests, you could use 9PFS to share a file system from a FreeBSD host, but there's not currently a way to share into a FreeBSD guest. I guess there might be if you use like a FuseFS version of 9P, perhaps that would work. I don't know if anybody has tried that.
Yeah, another issue is that there's no support for an EFI for it either. There is somebody has written a 9PFS EFI client, but that never got upstreamed. I mean, I guess it'd be kind of an interesting thing to try. However, VirtIO FS, which is the kind of successor to 9PFS, and is being pushed really hard by Red Hat, they have upstreamed the VirtIO FS client into EFI. So that may be something for us to pursue in the future.
Yeah, I think that's probably, for the long-term future, I think that's probably a better place to be than 9PFS. But we should probably support both for the foreseeable future.
Mm-hmm.
So the last question I saw on IRC before I check again is someone asked if there's any interest in letting Beehive pick up the memory settings, such as how much memory to use or if the memory is wired or not, from a prior invocation of Beehive load or grub to Beehive on the same VM. So you don't have to respecify them when you run Beehive. I think probably the solution to that mostly is don't use Beehive load and grub to Beehive and boot with EFI instead. Perhaps I haven't done it in my config file work, but it is not beyond the realm of possibility that some of the config file stuff I've done could be pulled out into a little library and Beehive load could reuse it so that you could use the same config file with both things. But I'm probably more in the camp of Beehive load is kind of a little more of an obscure use case. I know I use it because I get a little bit faster turnaround boot time when I'm testing kernels, which is what I care about. So I may still eventually try to allow Beehive load to use whatever config we use for Beehive. But I don't know that we have plans really to allow us to kind of query Beehive, kind of query what the VM already has and fall back to that at the moment.
It doesn't hurt, but you know, Beehive load and grub Beehive really should be moved to being obsolete. I mean, potentially for Beehive load, what we could do is just make it a front end to Beehive, where it just creates a VM and backgrounds itself.
Yeah, you could, or you could do something where Beehive kind of forks it and runs it and then resumes afterwards or something.
Yep.
Yeah, postpone when you actually, you could create all the devices and postpone the actual creation of the guest, kind of, or postpone the startup of the vCPUs, I guess is what you would postpone.
Yeah, so I mean, I think we don't really want to see further development in that if possible. And what I really want to see is a path to making them obsolete.
Yeah, I think I agree.
Yeah, we had a lot of, sorry, Peter.
Oh, I was just going to say, it's actually a lot of work. You know, these tools, they started out as just these little hacks to get things going, and then they've just turned into this big thing, and it's almost impossible to kill them. And in particular, grub Beehive, I mean, that was never intended to really be anything, but it ended up being useful for all sorts of other little things. And it's messy because it's out of tree. It's not synced, or I don't sync it. It's just too big a job. I know Chuck Tuffley has put a lot of work into kind of updating it so that it can support later versions of X4. But yeah, we really, it's just too difficult to kind of have these external loaders. They kind of need to be integrated into Beehive itself. And that's sort of how QEMU does it as well. You know, you have the option of running ROM, any sort of ROM, or you can have a like a built-in Linux loader, which it's kind of big in the container world just because they can get these boot times in the hundreds of milliseconds. There's no need to go and start up code in 16-bit and have yet another file system implementation in there. And that's, in a way, that's sort of what Beehive load does, except it's a separate process that's forked and exec, so it doesn't really help with speeding up boot times, I think. Maybe a little bit. I guess it is faster than
compared to Uefi doing stuff. Sadly, Uefi is a bit of a pig.
Yep.
Yeah, we had a lot of issues with Grub Beehive in the early days of our appliance. What happened was you would have an instance of OpenBSD, but then obviously the switches change because the version changes in OpenBSD as you uplift, and basically you lock yourself out of the device because your OpenBSD is your gateway router running as a guest. So when Uefi came along and was well supported in OpenBSD, that meant we could go pure UEFI, and we're not looking back from that point. We're UEFI all the way.
Yeah, I agree. That's really the way to go. I mean, when Beehive started, there was very limited and patchy support for EFI, but now it's just ubiquitous. All right, do we exhaust questions on IRC?
I think so. There was one follow-up question about, do any of our device models for disks support hot plugging? And my answer on IRC was not yet, or not currently, perhaps. Yeah,
also, Vnc SCSI might actually. I think that's another reason that you could use it.
There is desire to have some of the other models. I know one of the things Rob, that we mentioned earlier, is working on. He has a review I commented on a bit. For save and restore, we added a socket, a control socket, to allow Beehive Cuddle to talk to Beehive to ask it to do things. And currently it's just used for save and restore. Well, Rob is trying to make that socket more generic. And I know there are folks who are interested in being able to pass other messages, allowing us to do things like eject a disk or insert a new disk, like replace the media for a CD, or maybe also do a hot plug for VirtIO block, perhaps, I think was the other use case. So that may be one route that we might get to getting there. But we need to get the socket a little more cleaned up and standardized and not specific to save and restore first. And Rob's working on that. I also have interest in eventually having a hot plug PCIe in Beehive, but that needs some other work. We would have to be able to have a device model for PCI to PCI bridges, which is a bit of work. And right now, PCI doesn't do any, or the PCI support emulation in Beehive doesn't do any bridging, which makes it a little simpler to deal with. And this would add complexity, not just in the model, but in some of the other ways of how we register, like how we manage the registration of what things are active in the memory map and so forth. So it's a fair bit of work. At some point we'll add that maybe, but then we would still need the socket as a way to control actually triggering hot plug events from the outside as well.
So I had another approach for that, which was to do it by USB.
Okay.
So basically, currently, USB, it's a programmatic interface to get to an endpoint.
Yep.
Basically, what I was going to do there was just use a Unix domain socket and implement one of the many USB serialized protocols, and then you could just connect to that socket, which would simulate a USB device insert, and then you just have the protocol running via IPC across that socket, and then you can implement whatever USB device, which would be external to Beehive.
Yeah, so you could do pass-through very easily that way.
You could do pass-through. You could also, my idea was actually to use Beehive as the back-end process, because we already have kind of disk backends and network backends, and then just have that implement the target interface. And then you can just dynamically attach a disk or a network port or any kind of USB device. But once again, it's a reasonable amount of work. It's probably in the same ballpark as PCI hot plug. Although the nice thing about it is you don't need any kind of internal control. You know, there's just a socket waiting for an incoming connection. So you just have to fire something up and it just makes it connect, and then all of a sudden a USB device just magically pops up.
I think that's all the questions I can see.
All right, well, maybe we should call this a wrap.
Sounds good.
Thanks everybody for attending. Oh, sorry.
When is the next Beehive call?
Oh,
Office hours?
so I was going to try to do these once a month.
Okay.
I mean, if that's too much, I could push it out to 6 weeks.
No, I think once a month is fine. So let's see, this is the 4th week. So it'll be the last week of February, potentially. Okay.
We have just a housekeeping. We do have the minutes that go up on the Office Hours webpage. You'll see a link reasonably directly after this meeting.
And we should have the recording up shortly as well as the previous recording, which is not yet on the link from the wiki, but should be shortly.
All right.
Sounds good.
Thanks everybody for attending, and we'll hopefully see you all in a month's time.
Thank
Thank
you
you.
all.
Perfect. Thanks.
See ya.